It is indeed possible to position a 400 amp disconnect upstream of two 5 GaN meter sockets and subsequently subfeed both the GaN meter sockets and the corresponding panels situated directly beneath them. However, meticulous attention must be paid to ensure the correct bonding of the neutral and ground conductors and the proper execution of the subfeed to installation. Let's delve into the specifics of neutral and ground bonding. The neutral and ground conductors must be securely bonded at the 400 amp disconnect as well as at the electrical panels. Critically, these conductors should not be bonded at the meter sockets themselves. To achieve effective neutral and ground bonding at the 400 amp disconnect, employ a bonding jumper of appropriate size. Consult the National Electrical Code, or NEC, to determine the correct sizing requirements for the bonding jumper. The size of the bonding jumper will be determined by the size of the ungrounded conductors. For bonding the neutral and ground at the electrical panels, utilize the main bonding jumper typically supplied with the panel. Now let's move on to the subfeed process. The subfeed from the 400 amp disconnect to the meter socket should be implemented using a feeder cable designed to handle the anticipated amperage load. The feeder cable must also adhere to the sizing specifications outlined in the NEC. To effectively subfeed the meter socket, make use of a subfeed lug mounted on the rear of the meter socket. The subfeed lug should be sized in accordance with the amperage of the load it will carry. Several additional considerations are paramount for a safe and compliant installation. Firstly, the 400 amp disconnect must be located in a readily accessible area. Secondly, the subfeed circuit needs to be protected by a circuit breaker or fuse of appropriate rating. Thirdly, and most importantly, a qualified electrician should inspect the entire installation to guarantee adherence to all applicable codes and standards. Let's elaborate on each of these points to provide a comprehensive understanding. Regarding neutral and ground bonding, it's crucial to understand the underlying principles. The purpose of bonding is to create a low impedance path for fault current to return to the source, which facilitates the rapid operation of overcurrent protective devices such as circuit breakers or fuses. This minimizes the duration of a fault, reducing the risk of electrical shock and fire. In the context of the 400 amp disconnect, the bonding jumper connects the neutral conductor to the equipment grounding conductor, effectively bonding the neutral to ground within the disconnect enclosure. This is the primary bonding point for the entire system. At the electrical panels, the main bonding jumper performs a similar function, connecting the neutral busbar to the panel enclosure, which is then connected to the grounding electrode system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. It is essential to ensure that all connections are clean, tight, and corrosion resistant to maintain a low impedance path. Now, considering that the neutral and ground should not be bonded at the meter sockets. Meter sockets are typically considered service equipment, and per the NEC, the neutral and ground are only permitted to be bonded at one point in a service. Bonding the neutral and ground at multiple points can create circulating currents on the grounding system, which can lead to nuisance tripping of circuit breakers, electromagnetic interference, and potentially dangerous voltage on normally non-current carrying metal parts. This can also cause inaccurate meter readings and other operational issues. When subfeeding the meter sockets, the feeder cable should consist of 4 conductors, 2 ungrounded conductors, a grounded conductor, and an equipment grounding conductor. The ungrounded conductors carry the current to the meter sockets. The grounded conductor provides a return path for the neutral current, and the equipment grounding conductor provides a low impedance path for fault current. The size of the feeder cable should be determined by the amperage of the load served by the meter sockets, as well as the length of the feeder run. The NEC provides tables and calculations to determine the appropriate conductor size based on these factors. Voltage drop should also be considered to ensure that the voltage at the meter sockets remains within acceptable limits. The subfeed lugs used to connect the feeder cable to the meter sockets must be appropriately sized for the conductor size and amperage. These lugs should be listed and labeled for the intended application and should be installed in accordance with the manufacturer's instructions. In addition to the electrical considerations, it's also important to consider the physical installation of the equipment. The 400 amp disconnect should be mounted securely in a location that is readily accessible for maintenance and repair. The disconnect should be protected from physical damage and environmental factors such as moisture and corrosion. The meter socket should also be mounted securely and protected from physical damage. The wiring should be neatly organized and supported to prevent strain on the connections. All work should be performed in accordance with good workmanship practices and in compliance with all applicable codes and standards. The requirement for a readily accessible location for the 400 amp disconnect is based on the need for quick and easy access in the event of an emergency or for routine maintenance. The NEC defines readily accessible as being capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. This means that the disconnect should not be located behind locked doors, in inaccessible attics or crawl spaces, or in other locations where it would be difficult to reach quickly. The overcurrent protection requirement for the subfeed is intended to protect the wiring and equipment from damage due to overloads or short circuits. The circuit breaker or fuse should be sized to protect the feeder cable and the meter sockets. The NEC provides guidelines for selecting the appropriate overcurrent protection device based on the ampacity of the conductors and the characteristics of the load. Finally, the requirement for inspection by a qualified electrician is crucial to ensure that the installation meets all applicable codes and standards. A qualified electrician has the knowledge, skills, and experience to identify potential hazards and to ensure that the installation is safe and reliable. The electrician should inspect the wiring, the connections, the grounding system, and the overcurrent protection devices to verify that they are properly installed and functioning correctly. The electrician should also perform tests to verify the integrity of the insulation and the continuity of the grounding system. In summary, installing a 400 amp disconnect to feed two 5-gang meter sockets is a complex task that requires careful planning and execution. It is essential to understand the principles of neutral and ground bonding, subfeed wiring, and overcurrent protection. All work should be performed in accordance with the NEC and other applicable codes and standards. And most importantly, a qualified electrician should inspect the installation to ensure that it is safe and compliant. The NEC, specifically Article 250, addresses grounding and bonding requirements in detail. It emphasizes the importance of creating a low-impedance path for fault currents to facilitate the operation of overcurrent protective devices. This article outlines the rules for grounding electrode systems, equipment grounding conductors, and bonding jumpers. It also specifies the requirements for bonding different types of metal enclosures and equipment. Article 310 of the NEC covers conductors for general wiring. This article provides tables and calculations for determining the ampacity of conductors based on their size, insulation type, and installation conditions. It also addresses the requirements for conductor identification, conductor protection, and conductor terminations. Article 408 of the NEC covers switchboards, switchgear, and panel boards. This article outlines the requirements for the construction, installation, and overcurrent protection of these types of equipment. It also addresses the requirements for the location and accessibility of panel boards. Article 230 of the NEC covers services. This article defines the requirements for the service entrance conductors, the service disconnecting means, and the service overcurrent protection. It also addresses the requirements for the grounding of service equipment. Additionally, the local electrical codes and regulations may have additional requirements that must be followed. It is important to consult with the local authorities to ensure that the installation meets all applicable requirements. It's also worth noting that the specific requirements for the installation may vary depending on the type of building, the occupancy, and the local utility company's requirements. For example, some utility companies may require the use of specific types of meter sockets or disconnects. They may also have specific requirements for the location and accessibility of the equipment. It is important to coordinate with the utility company to ensure that the installation meets their requirements. Proper documentation is also essential for any electrical installation. The electrician should provide a detailed wiring diagram showing the layout of the system, the location of the equipment, and the size and type of conductors used. The electrician should also provide a list of all the equipment used, including the manufacturer, model number, and serial number. This documentation should be kept in a safe place and should be readily available for future reference. It's also a good idea to take photographs of the installation before it is concealed by walls or ceilings. These photographs can be helpful for troubleshooting problems in the future. In addition to the technical aspects of the installation, it's also important to consider the safety aspects. Electrical work can be dangerous, and it's important to take precautions to protect yourself from electrical shock. Always disconnect the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Be aware of the potential hazards and take steps to mitigate them. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Electricity is not to be taken lightly, and it's extremely important to have the knowledge or hire someone who does. There are many resources available to help you learn more about electrical safety. The Electrical Safety Foundation International, or SFI, is a non-profit organization that provides information and resources on electrical safety. The Occupational Safety and Health Administration, or OSHA, also has information on electrical safety in the workplace. The National Fire Protection Association, or NFPA, publishes the NEC, which is the standard for electrical safety in the United States. By following these guidelines, you can help ensure that your electrical installation is safe, reliable, and compliant with all applicable codes and standards. Remember that electrical work is complex and potentially dangerous. If you are not sure what you are doing, it is always best to consult with a qualified electrician. They are trained to handle these types of installations and can ensure that the work is done safely and correctly. Electrical codes are constantly evolving and being updated, so it is also important to ensure that you are aware of the latest requirements. Staying informed about the changes in the NEC and other applicable codes will help you to avoid costly mistakes and ensure that your electrical installation is up to code. Remember to prioritize safety at all times when working with electricity. There is no substitute for knowledge, skill, and experience when it comes to electrical work. If you have any doubts or questions, don't hesitate to seek professional assistance. A well-planned and properly executed electrical installation will provide years of safe and reliable service.